Hello everyone, welcome to our YouTube channel Learn Electronics India. So we are continuing with our basic electronics series. This is the lecture number 2 or the session 2. So if we recall our previous session, in the previous session we had a problem statement where when we attach a 9-volt battery to a LED, we are not able to on the LED properly. I mean the LED got damaged. So this was the problem statement, and I got the beautiful comments in our comment section that one of our friend have explained it properly. That is, the amount of voltage that is supplied to LED is more, or the current rating of the LED is more. So if we see it in the terms of water analogy, the water flow is more, which the bucket can't resist, or the bucket just broke out. That is the reason. Cool. So what we need to do? We need to control the flow, right? So there is the device, or there is a component called resistor. So when you attach a resistor in the circuit, then we can see this LED is operating properly. So today we are going to learn on resistor. So our topic on resistor. So resistor is an electronic component which resists the flow of current such a way that we can control the circuit. So generally we have 4-band and 5-band resistors. If we can see this resistor, this 4-band resistor, now we will see how to read the particular resistor. That is, if I give you a resistor, I want you to tell how much resistance does this particular resistor have. Then we can use this chart that is on my right on this side, and we can easily tell the resistance of that particular resistor. So let us read this out. So we will start from left. So the first one will be the first band. So if you can see the first band is in the color of brown. So we will see the first band which is brown. So its number is going to be 1. So the second band is black. So the second number is black. So that is 0. So 1, 0. And the third band is generally be the multiplier. So the third band is an orange color. So we'll take the orange color to the third band. So which we multiply with 1 kilo ohm. So 10 multiplied with 1 kilo ohm gives us 10 kilo ohm. And the fourth band represents the tolerance. So tolerance of this particular resistor is in the color of gold or silver. So if we can see, gold is plus 5% and silver is plus or minus 10% and plus or minus 5%, right? So altogether, this particular resistor is of 10 kilo ohms resistor with plus or minus 5% or 10% of tolerance. Tolerance generally means an instability in the resistance. So it can either be 1 kilo ohm plus 10% or 1 kilo ohm minus 10%. Okay. However, you can get a precise, accurate resistors, but that would cost some extra amount. So now we'll go to the next slide. So this is a funny meme that you have already seen in many of the electronics pages. So the ohm resembles the resistance. The unit for resistor is ohm. Okay. So this resistor is not allowing the ampere, or it is controlling the flow of this ampere. cool image. So this is not allowing this ampere to flow. I mean, this is not allowing the water to flow through the pipe. If we recall the water analogy, if you're thinking about what is this water analogy, please visit our previous video where I have detailedly explained about what does voltage mean and what does current mean. Cool. So this is a cool meme that I want to share to you. So now, with that being said, we can see the symbol, how we represent a resistor. So these Vrigil lines, or this these speed breaker lines, I call sometimes, which, what does this do? If you recall this pipe, so if we have a shape of such pipe, what happens to the flow? The flow need to get slowed down because of that Vrigil or that speed breaker shaped pipe, right? So that is what the resistor do. So with that being said, we just recall all the symbols that we have learned so far. So there are 3 symbols with us in our pack. Like we learned what is the symbol of a battery. We learned what is the symbol of an LED, and today we have learned the symbol of resistor. Okay, so now we will go for the design for us for today. So as we know, to make a beautiful design or the product to come out, we need to follow 4 steps. That is, you need to draw a circuit diagram. Number 2, you need to make a simulation of that particular circuit, followed by you need to do a prototype model, and then you will have your final model, which is generally done in PCB, or you just solder entire setup. So today we are going to make a battery level indicator where we have LEDs and resistor connected such a way that we can know the battery level on the of the particular battery attached to the circuit. So with that being said, I want you to pause the video and try to put that particular circuit on the paper. Try to put the circuit on the paper. Pause the video and try to put the circuit on the paper. Yes. So I hope you have put the circuit on the paper. So the circuit looks something like this. So what I have done is I have used 3 LEDs and I have connected the resistors. I connected the resistors. Please note all the resistors are having same resistance. So I have used 1 kilo ohm, or you can even use 5 kilo ohm resistance. I have tested that, and I have connected I have connected the LEDs in this pattern, and this voltage we will vary such that we can see the brightness of the LEDs, and we can come to the conclusion that how much voltage does this particular setup or this particular battery have. Cool. So now the next part of any design is simulation. So as I have said, we have done a beautiful series how to make your own simulations using Tinkercad. Please visit our YouTube channel where you can see the simulation, how to make your simulation models. So this particular simulation I have done in Tinkercad. So if you can see this particular simulation, when I give a 3-volt battery, so you can see only one LED is glowing, the red LED is glowing, right? So other 2 LEDs are not glowing, which resembles the particular battery is having 3 volts, 3 volts. So the next, when I connect a 9 volts in 9 volts battery, you can see all the 3 LEDs glowing. So which resembles the battery is full, the battery is full. So now we come to the prototype model. I have done the same prototype model. The battery that I have is a LiPo battery or lithium polymer battery. So where its nominal voltage is about 3.7 volts. So when I put a 3.7 volts battery to the circuit that we have designed, the LED is glowing, only one LED is glowing. So what I have done, when I connected 2 batteries in series, so when you connect 2 batteries in series, which means that you add the voltages. So it's like 3.7 plus 3.7, which results into give you how much? It's 7.14, right? Yes. So it's nearly like 7 volts. Then you can see 2 batteries glowing, 2 LEDs glowing, 2 LEDs glowing. So on the next, what I did was I connected a 9-volt battery with a series of another battery. So then you can see all the 3 LEDs glowing, all the 3 LEDs glowing. So you can even do this way, like you take the 9-volt battery, which is half of its voltage, like it's having only 4 volts. And when you connect it to the circuit, you can see only one LED glowing, just like this particular picture. So when you connect a 9 volts battery, which is having approximately like 6 to 7 volts, so you can see only 2 LEDs are glowing. So with that being said, you can know the particular voltage level of the battery and you can use it to your particular application, right? Come on. So now this is the final design that I have done. I didn't use any PCB. I just soldered all the LEDs with respect to the circuit using the circuit diagram that we have done as the reference. So that's it from my side today. Thank you for watching. And if you have any doubts, please put it in the comment section. If you like the video, please like it. And please share it with your friends so that they can also enjoy this basic electronics thing. Thank you.